Another way that students can add and subtract fractions is by using more manipulatives, or they can draw these. I actually used to draw these on my papers to figure out fractions. So this is a hexagram, usually that represents one whole. This usually represents a half. This would be a poor color choice. Hold on. This would be a third. And traditionally this would be a sixth. Can you see that? Let me zoom in. And here is your sixth. Okay, so I love using these for fractions. I think it's the coolest thing ever. Okay, so I'm going to start small. One half plus 2/3. Let me zoom y'all back out. 1/2 plus 2/3. Okay, so here's my whole. Here's a half. 1/2. So I'm going to go ahead and take the whole away. 1/2 plus, here's my whole back, 2/3. So we discussed that these represent thirds. Okay, so we have two of them. So we're trying to combine 1/2 and 2/3. Well, what's difficult about this is we don't know how to combine these because they are two different shapes. So we're not really sure what to say here. So what I'm going to do, I'm going to take this whole back and I'm going to try to figure out what shape I can use that will evenly represent both of these shapes. So I'm going to go ahead and I'm going to take these triangles and I'm going to see if it will evenly represent both of these shapes. And the triangles do. So according to the triangles, when we use those, this half right here becomes 3. 3 what? You can move them over down to the half to figure out how many triangles would be in a whole. And the answer is 6. So since there are 6 triangles in the whole, 1/2 is the same as 3/6. Okay, so now we have the 2/3. And it's looking like 1/3 is the same as 2/6 because 2 of these triangles fit within this third, or this rhombus. So that means that 2/3 would be the same as 4/6. So I'm going to take 3/6. I'm going to move all these back. There's my 3/6. And now I need 4/6. Let's see if I have enough. I'm just going to make one real quick. There we go. So here are my 4/6 and my 3/6. So it's looking like I now have 7/6. Now, if you're allowed to complete your answer with an improper fraction, you're finished. If you need to switch this to a mixed number, which usually you should, so we can try to put these into a whole. So there's my whole, and how many do I have left over? 1. So this becomes 1 and 1/6. So the answer to my problem, 1/2 plus 2/3, is 1 and 1/6. Okay, so what if this was subtraction? let's do okay, so I made more of a complicated one this time. 5/12. So how can we represent twelfths? We only have these little bitty triangles, and these are sixths. So how can we represent twelfths? So for my whole, instead of using one hexagon, my whole is gonna become 2 hexagons. So this is my new 1 whole. Since this is 1 whole, 1 triangle becomes 1/12 instead of 1/6. So now we need to figure out what 1, instead of 1/3, let's do 1/4, just to make things a little bit easier. So now I need to figure out what 1/4 of this whole would be. Well, before, this was a half. So since we have double now, this becomes a 1/4. Okay. So now we're going to try to figure out what can we use to evenly represent both of these shapes. So I have 5/12. So here are my 5/12. And I'm going to subtract 1/2. So this is where the shapes make everything so much easier. Watch this. So I'm moving the shapes, the 12ths, and I made them look the exact same as the 4th. Do you see that? These are the 12ths, and I made them look the same as the 4th. So now all I have to do is look and see what I have left over. What do I have left over? 2/12. Okay, so if I were to do that with standard algorithm, I would have had to find a common denominator, which is kind of what I did with the shapes. You just didn't have to think about it quite so much because you were already in 12ths. So, 4 does go into 12. You're going to multiply by 3, and you're going to get 3/12. So 5/12 can stay the same, and you're left with 2/12.